In this video, we'll look at section 1.2. We're going to solve some formulas out for different variables. Those are called literal equations. We're also going to look at exponents and the exponent laws and scientific notation. So this should be review, but you might be rusty, so go through. You might want to try them yourself first and then check. But number one, we're going to solve the formula for the indicated variable. B sub 1 plus 25 equals 4 times B sub 1 minus 5 times B sub 2. And we're solving for B sub 2. So the first thing I need to do is get my variable term that has B sub 2 on the right hand side by itself. So I'm going to subtract 4B sub 1 from both sides. And I do have another B sub 1 over there on the left hand side, so that will become negative 3B sub 1 plus 25 on the left hand side equals negative 5B sub 2. The thing that's left to do here is divide both sides by negative 5 to get that B sub 2 by itself. So I'm going to go ahead and do that. We need to make sure we get that whole left-hand side divided by negative 5. Now, I need to, I'm going to write over to the right here. I'm going to put B sub 2 on the left-hand side by itself because I always want my variable in the final answer. I just want to have it on the left is a typical way to write it. Then I have this negative 3B sub 1 over negative 5, and I'm going to split this up so I'm real careful and I don't have the bad habit of some bad canceling. And then I have plus 25 over negative 5, and I'm going to look to see if I can reduce. And I can simplify here because I have I have B sub 2 on the left-hand side, and then I have my negative 3B sub 1 in the numerator over a negative 5. That gives me a positive 3/5 B sub 1 plus the 25 divided by the negative 5. I can just write that actually as a subtract 5. And that would be my final answer on that one. Okay, number 2 is very similar. This is the formula for an area of a triangle, and if I had, let's say I knew the area and the base and I always wanted to find the height, I might want to derive a new version of it. So I'm just going to take this half B is what I need to divide by, but dividing by a half is really the same as multiplying by 2. So when I do this A divided by a half B on the left hand side, so I started with A equals a half B times H, and now I'm dividing both sides by a half B to get that H alone on the right hand side. So when I divide by a half, that's really going to be multiplied by 2, so I end up with 2A in the numerator and a B in the denominator. And then again, I'm just going to rewrite this, the H on the left-hand side equals 2A in the numerator divided by B. And that would be my final answer. Now we're looking at exponents. Simplify and write with positive exponents. So in number 3, we have parts A, B, C, D, and E, so it's kind of a lot, but they're short. And it's really a good idea to memorize your exponent laws. This should be reviewed, but a lot of times if you haven't done it in a while, you might mix some things up when they get complicated, when you have more than one step. So I posted a document in there in your module for this so that you can look at that. They're also in your book. So the first one, we need to apply our product to power rule. So number 3A is parentheses negative 3x to the 6th power close parentheses all raised to the third power. So I'm going to separate that out. So I need to take each factor in there. So the -3, I'm going to put parentheses. That's important, especially if you were raising to an even power, that would affect your sign. So I have -3 in parentheses cubed. Then I have x to the 6th cubed. Now I can apply my power rule. So -3 cubed is going to give me -3 times -3 times -3 is -27. So we can just calculate that out. Sometimes I have you leave them in exponent form. I can, I'll specify on a test or a quiz. So x to the 6th raised to the third power, that's like 3 factors of x to the 6th. So we would have x to the 18th. So we multiply our exponents when we're raising. So my final answer is -27 x to the 18th power. For part B, we have x cubed times x squared. Now this one seems pretty straightforward. Well, if I have 3 factors of x there, and then I have another one that makes 4 factors, and then the x squared would give me 6 factors. So B would be x to the 6th. What some people do, they forget this. If there's not a power written in, just that plain x, sometimes putting a 1 there helps because they just forget to add that 1 in. If you're just keeping the base the same and adding exponents is our exponent law, they forget to add that 1 in. So if you tend to do that, then I would suggest put the 1 in. -8 to the 0, well, actually we would do the exponent portion first. That negative's outside, but anything raised to the 0 power, that is going to be 1. Negative. So we end up bringing the negative down. 8 to the 0 is 1. So we have -1 is our final answer. So be careful of that one because the negative is not in parentheses, that -8. Now part D, we have x times parentheses x to the 5th power, close parentheses, raised to the 7th power. So for now I'm going to keep the x just where it is, that starting x, and then I'm going to apply the power rule to x to the 5th raised to the 7th. So I'm going to multiply my exponents there. So I have x times x to the 35th power. Now I need to apply this product rule of when I multiply exponentials with like bases. We can only do this with like bases. I know that plain x is really like x to the 1st, so I'm going to add the exponent. So I write down x for the base to the 36th, and that would be my final answer, x to the 36th power. Now on E, I have a few different things going on. You can always look in the parentheses to see if you can simplify first. So this one we have parentheses, and then I have a fraction. 2 times y cubed in the numerator, all divided by 3x in the denominator, close parentheses, and all of that is raised to the 4th power. So if I look in the parentheses, I really don't see anything that I can reduce easily or simply. So I'm going to, because I want to leave things in fraction form, not convert to decimal or anything. So I'm going to take each piece in the numerator. That would be 2 to the 4th. And then y to the 3rd raised to the 4th would be to the 12th. In the denominator, I need to do the same thing. 3 to the 4th times x to the 4th. And now I just need to make my calculations for my number part. So I have 2 to the 4th would be 16. And then the y to the 12th is up in the numerator. And then 3 to the 4th is going to be 81. and then I have my x to the 4th. So my final answer is 16 y to the 12th in the numerator, all divided by 81x to the 4th. Okay, so now we're moving on to scientific notation, and we're going to apply those exponent laws. I did write you a note here. It says memorize exponent laws, see handout in Canvas. So I'm going to push this up now. So we have scientific notation, number 4. Compute and answer in scientific notation. So what scientific notation means, again, this is in your textbook, so you should take a look at that, even if you're just choosing to submit videos for your grading purposes for this assignment. It's always a good idea to look through your book, make sure you know the ins and outs, especially if if it's been a while since you've done this. Scientific notation means that the first number, the first factor for the power of 10 is going to be a number between 1 and 10. It could be 1, but it can be up to 10. So if we could end up with like 9.2 or 9.99 would be okay. And then it's times 10 to a specific exponent, depending on how large or small. So if it's a positive exponent, it's a very big number. If it's negative, it's a very small number. So for this first one, for A, we have 4 times 10 to the negative 40th, all in parentheses, times 6 times 10 to the negative 16th, or 16, all in parentheses. So what we want to do is treat it just the same way as our exponent laws, that the 4 and the 6 are kind of like the coefficients, so to speak, and the 10 to the negative 40 and the 10 to the negative 16 that's really our exponential. So we're going to multiply our coefficients. 4 times 6 would be 24, and then that x is really a times symbol, because that's just how the notation is done. Then I keep the base, 10, and I add the exponents just the same as I would for my, if I have variables involved to exponents, I'm going to add them. So I have negative 40 plus negative 16, so that gives me negative 56. When I'm multiplying, I'm going to keep the base, add the exponents. Now this is almost done. It's correct, but it's not complete because it's not in scientific notation as specified. So in order to do that, I would need to make this 24 be 2.4. And I'm manipulating here. These are factors, so I can kind of, if I want to divide this factor by 10 to make it be 2.4, I would really have to add another power of 10 over here and multiply that to compensate. So this power then would be one higher. It's negative, so we're going to go 10 to the, instead of negative 56, it's going to be negative 55 because I'm adding 1 up there. So my final answer is 2.4 times 10 to the negative 55. For part B, we have 2.2 times 10 to the 20 in the numerator, and it's understood that there's parentheses around even if they're not showing. Any numerator as a grouping symbol and denominator is also a grouping symbol. So in the denominator we have 8.8 times 10 to the negative 50. So again, we're going to follow the same concept. We're going to divide 2.2 by 8.8, and since these are decimals, I can just put it in decimal form. Scientific notation, that's common to do. We wouldn't necessarily leave it in a fraction form. So we would end up with 0.25 as our first number, and then times, keep my base 10, but I'm going to subtract the exponents. I'm going to do this off to the side. So I would have, because I'm dividing, I want to subtract exponents. That's my exponent law. 10 to the 20 minus negative 50. So again, that double negative becomes a positive. So I would have 10 to the 70 as my second factor. But now again, this is 0.25 is not in scientific notation, so I would have to actually multiply by 10 to make that be 2.5. So my other factor has to be divided by 10 to compensate. So this exponent of 70 has to be reduced by 1 power of 10. So it would be 10 to the 69. So I end up, my final answer is 2.5 times 10 to the 69. And that's it for this topic. And I encourage you to read through your book, review the exponent laws. If you really need more of the nuts and bolts, there's some additional videos that you can watch, and also some additional notes and practice and things like that. So thank you for watching. Have a great day.